The popular image of software development is of some lone genius creating great software, usually alone in their bedroom somewhere. Then the software goes on to take over the world. Or alternatively, it's something that people think is difficult but boring and repetitive. While there are seeds of truth in both of these ideas, I think that software development is very different to either of these rather dumb stereotypes. Software development done well is really a team sport. And while it's true that the technical details can bore some non-technical people, in reality, it's a deeply creative, challenging, rewarding discipline, or at least it can be. So if it is a team sport and we need great teams to do well, what makes a great software development team? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content today, hit like as well. I've talked about different aspects of this team focus before, and I like the team topologies model for team organization. But today I want to explore this problem from a slightly different angle. I talk about a range of different practices and approaches to software development on this channel that have served me and the teams that I've worked on well for a very long time now. One of the commonest pushbacks that I get to these ideas though is, yes, but how can you do that with inexperienced people? Or how can you do this if the team's not very good? Or how can I do this if the team doesn't really care? Well, it seems to me that this is either a bit of a straw man question or it's focusing on the wrong problem. This is most commonly asked about trunk-based development, but people also ask it about evolutionary design, test-driven development, acceptance testing, and nearly everything else that I think helps us to build better software. The simple answer is you can't build good software with these techniques or any other with unskilled, poorly motivated people who don't want to take responsibility for their own work. That's just true, whatever the nature of your approach to software development. Before I progress much further, please let me say thank you to our sponsors. We're fortunate to be sponsored by Equal Experts, Tricentis, Transfic, Roost and Sleuth. All of these companies offer products and services that are well aligned with the topics that we discuss on this channel here every week. So if you're looking for excellence in continuous delivery and software engineering, please do click on the links in the description below to check them out. I think software development is a difficult thing to do well. There are no cookie cutter solutions here. Everything is conditional to some degree. Should you always write tests before you write code? Well, yes, of course. Except there are some exceptions. Times when I don't always start with a test, though I'm a big fan of test-driven development. Is trunk-based development best? Oh yeah, the data says it is. But what about open source projects? Well, of course, those are a different kind of thing where the techniques like feature branching and pull requests were designed to operate. This conditionality is everywhere because this is a very complex discipline. These things are always conditional, even though in the vast majority of circumstances and for the vast majority of projects, they're very good advice. I think that there are some foundational ideas that are always true, but they are very few and far between. Most of the time, decision making in software is nuanced and takes understanding, insight, and yes, intelligence. We need smart people doing smart things to the best of their ability to do a good job. The people that push back with yes, but crap people responses are obviously right in one way and profoundly wrong in another. Of course, we can't build great software or even good software with low-skilled, unmotivated people, but attempting to micromanage people like this to direct what they do in detail in order to achieve success by defining requirements that really only define solutions and not the problems to be solved, by predefining the design or architecture rather than allowing these things to evolve as part of the development process, these things don't work either. Neither does always gatekeeping people so that someone senior okays every commit that people make. and someone else always tests the code for them before it's released. If you'd like to learn more about what I think really does work better, check out my training course, Better Software Faster, that describes what it takes to practice the most effective approach to software development that we know of so far, continuous delivery, and how and why this approach works so well. To do better in software development then, what we'd really like is for everyone to have the skills that they need to be productive. Be willing to take responsibility for their own work, and for people that are motivated to do a good job in the interests of the team and the users of the software. Let's look at the problem in a bit more detail. I've talked about these two problems before in several different videos. I generally refer though to these two anti-patterns as programming by remote control and gatekeeping. The problem is that in order to do good software development, let alone great software development, it takes a lot. We need to understand the problem that the users have thoroughly and in detail. And for that, we need to understand what they do and how they use our software to do it. We need to find a good design that meets the needs of these users, but also there's a lot of stuff that we need to consider as software development professionals because others won't think of them. Managing technical debt, scalability, resilience, security, testability, and maintaining our ability to continually change our systems are just one set of examples. We need to make sure that our systems are fast enough and nice enough to use. And we need to keep up with changes in our technology and keep an open mind on changing our approach when we learn new things. Oh, and we need to do all of this and probably a lot more in small teams. And the data says that for this to work, these small teams need to be able to make progress without depending on others outside of the team. The State of DevOps report consistently finds that one of the most significant predictors of high-quality software produced quickly is that teams can make progress without relying on other people outside of the team. So it's easy then. All we need are superhuman teams that know everything about software development and are complete experts in the problem that they're working on. Oh, and that understand everything else that it takes to release their changes into production too. Well, yes, that is what we need. But it's not quite as bad as it sounds. The classical response to this problem is, well, that's clearly impossible, so we'll do what we do in the physical world. We'll decompose the work into smaller, simpler steps so that people don't need to be so super smart and know everything. This isn't a stupid idea, but how we usually divide things up doesn't work very well at all. What we usually do is to create some kind of overly naive process flow, identifying the common tasks that occur in software development and organising the people into groups to perform those tasks in a series of discrete steps, one after the other. We end up with a kind of cookie-cutter production line, which is a complete mismatch for a creative process that is fundamentally about learning. This is never going to work because learning is always iterative. We need to try out ideas, explore different choices and figure out over time what works and what doesn't. A waterfall production line is never going to work unless we know all the answers at the start. Fundamentally, what we need is the ability to make mistakes and then to deal with them, rather than seek some illusory perfection of understanding from the beginning. It seems in some circles these days to be fashionable to dismiss the existence of waterfall, thinking that was done, that was in the past. But if you have a product owner allocating work to individuals on your team, individuals owning responsibility for components or other small parts of the code, technical layering in teams, architects or UI designers doing work for each feature before it's released to the development team, then this is a waterfall. It's a sequence of steps that need to happen in order, with little or no iteration that allows you to correct if somebody upstream makes a mistake. Fundamentally, the problem here is that software development is more complicated than this. I can have an idea as I'm writing some low-level code that completely invalidates architectural assumptions up to this point. If I'm working in the code, I may come up with a solution that is dramatically better and easier to implement, but only if I understand the problem that I'm working on. And I'm not working on some predefined solution that was created by somebody else somewhere else upstream, usually a long way away from the code. To solve this problem, we must get knowledge of the problem into the development team. And we must give them the freedom and responsibility to come up with different and better solutions if they can find them. The people in the development team are in the code, so they will see problems sooner and more clearly than anyone else. So if we want to make this process as efficient as it can be, we need them to be responsible for fixing any problems that they find along the way. We need the development team to be responsible for the design of their solutions, evaluating that they're fit for purpose, that is testing, and organising themselves to better be able to solve the problems at hand, whatever it is that crops up. So if breaking the problem down into a waterfall of small steps doesn't work, what does? I said earlier, we need to be able to optimise for learning. We need to be able to iterate to be able to learn. The scope of that iteration is one of the useful tools that we can use to define what we mean by taking a step. The small steps idea is a good one. We need to organise our work into very small steps so that we can manage the otherwise impossible cognitive load. Without that, it would mean that we'd need those teams of superhumans. What we do instead is to break things into small steps, but organise those steps so that they are in line with the loops of iteration that we're carrying out, that are essential if we are to be able to learn as we go. Two simple examples of this are the commit stage and acceptance stage in a deployment pipeline. The commit stage is the fast stage that runs after each small change, each tiny step, and it answers the question, does this look good enough for us to safely move on to the next small step? And the acceptance stage answers the maybe more important question, but does this look like it's ready to be releasable? They allow us to proceed in small steps, but with a lot of confidence. Another way in which we can divide up the work into smaller steps is that we can separate the good description of the function of our system, our requirements, from the implementation detail of our system, how our solution actually works. We can also decompose our organisation into many small teams, each responsible for a small part of the system, but in a way so that they're responsible for all of that small part. We avoid teams divided along technical divisions and prefer teams aligned with the problems we are solving, stream-aligned teams. This minimises dependencies between the teams for day-to-day work and reduces the overheads and bureaucracy of moving work between the teams. Instead of a sequence of waterfall-like steps, it's more like a shower of drips. Each can fill up a container that represents all of the features in our system, but one is a single stream and is more prone to being blocked or slowed by a single problem. The other is a distributed system that is hard to stop from filling the container, whatever else happens. Making development, and particularly decision making in development, a more distributed process is more robust and more scalable as an approach. So how do we solve the problem of making sure that each of these small teams has the skills that they need and is willing to take on the responsibilities that they need to make all of this work? I start from the assumption that most people, certainly most people in software development, want to do a good job. I know that there are lots of organisations where this doesn't seem to be true, but I still think that it is. What I see and believe to be true is that the system, the process, almost forces people not to care and not to take responsibility for their work. I am a recreational sailor, and I once got the chance to join a much more experienced crew to sail a yacht between two countries. This was a journey of over a week at sea. One of the crew, let's call him Joe, decided that I didn't know what I was doing. So they micromanaged me the whole time. For some things, they were right. I didn't know what I was doing and I needed the help. But for others, I'm certainly a reasonably experienced sailor, albeit for a simpler style of sailing. At one point, I found myself staring at some messy ropes, thinking somebody should tidy those ropes. but I'm not going to do it because Joe hasn't told me to do it. This is not me. This is not how I usually do things. And as soon as I realized what I was doing and what I was thinking, I went over and I tidied the ropes. Later, I noticed Joe retidying them because I hadn't done it in exactly the correct way that he preferred. I see the equivalent of this all of the time in development teams. If you organise things to take responsibility away from a development team, then they won't be responsible. That will reinforce theirs and other people's opinion that they aren't and can't be responsible and can't be trusted to do things without being micromanaged or gatekept. If you correct people when they do things differently to how you prefer them to be done, even if both are equally valid, then they will never learn and you will never do better than you alone can do. You remove their ownership of the problem and limit their ability to learn. I don't think that my tidied ropes were actually any worse than Joe's. They were just done differently to what Joe expected. But even if my version of rope tidying was worse, it would have been much better for Joe to have shown me how to do the better job, let me do it, and then I would have learned what to do and he wouldn't have had to redo the work himself. This mistake is exactly the same mistake that we make when we decompose work in the wrong way for development teams. If you don't trust your development teams to design solutions, create user interfaces or test their own code, then they will never improve to become trustworthy. As long as you don't give them room to try and yes, maybe even make some mistakes while they're trying, they won't learn to do a better job. Most of my experience has been that as soon as you give teams responsibility, they will take it on. They may not have all of the skills that they need in the team, like me sailing across an ocean, but they will have other skills that can help. And they'll be able to improvise solutions in other areas that they're not familiar with. This isn't always good enough. Sometimes teams will miss important things and optimize to make their lives easier at the expense of other, maybe even more important things. Regulatory compliance, quality and security spring to mind. So just leaving teams to it isn't good enough either. But giving them real responsibility, and that also means giving them the freedom to make decisions for themselves without asking for permission elsewhere, is an important step forwards. This is about removing the micromanagement. It should be acceptable for development teams to pick their own solutions to problems and to have freedom to allocate time to improving things. The other part of the equation is helping them to build their skills and understanding. We can do this through the requirements process by ensuring that requirements are real requirements, something that the user really wants of the system, and are communicated as such to the development teams, rather than predefining a solution of some kind that is really just programming by remote control. For this to work, we also need to support the team in areas where they lack experience or expertise. It's not good enough to say to a development team, you're autonomous, you're responsible, and then give them no help. So you need to allow them to make real choices about their work, but also support them with real help. It's not good enough to expect them to make decisions in areas beyond their level of experience or expertise. This is the other dimension of scaling up, and now we're firmly in team topologies territory. We divide the organisation into small teams, most of them focused on specific functions of the system, from the perspective of users of the system. These stream-aligned teams are responsible for their own work, but not without some assistance and support. The idea of reducing cognitive load is not to remove responsibility from those teams. It's not the job of platform teams, enabling teams or complex subsystem teams to take over responsibility from stream-aligned teams for the features of the system that the users need. Their job in those other teams is to make it easier for the stream-aligned teams to meet those user needs. Enabling teams in particular can help stream-aligned development teams to grow their skills and knowledge. If a stream-aligned development team needs to implement a feature that is beyond their experience, a tricky usability problem, something that challenges architectural assumptions that have worked up to this point, or maybe a particularly tricky problem in data storage, then they can borrow some help from an enabling team, some expertise to help them to solve this more unusual problem. The job of the person from the enabling team is to add some of that missing expertise to help the stream-aligned team to meet its immediate goals, but also to coach the team to grow their skills a little bit more in the expert's area of expertise, so that in future they'll be able to do more of the job. Fundamentally, the job of anyone outside of the team is to offer either guidance or support, but not to allow the team to abdicate responsibility for their work to anyone else outside of the team. Despite fears of teams not being up to this, in my experience it works remarkably well. And I go further. In fact, I've never seen good software development in the absence of this kind of responsibility and ownership within the development team. Thank you for watching, and if you enjoy my stuff on this channel, please do consider supporting our work here by joining our Patreon community. Thanks again, and thank you to our Patreon supporters.